Okay, welcome back to the second videos of this video chapter. That is chapter number 10, Gravitationals. In the previous videos, I have just highlighted some introductions about the gravitationals. We have discussed that what is gravitationals. I'm just re-highlighting and rewinding all those video topics that we have discussed in the previous video lectures. In the previous video lectures, we have discussed that Sir Isaac Newton was the first scientist who have given the ideas about the gravitationals, and how when the apple fall on his head, okay, he start wondering that how this apple fall and why this apple fall towards the ground, means toward the earth. Okay, why does it falls in the upward direction, means towards the sky. Okay, so he start wondering, and then they start formulating a lot of theories. Okay, so after this, they have come across that Earth in the universe. Okay, in the universe there is a gravity, there is a force, and that force, okay, that force is what we call in entire universe. Okay, in the universe, all the objects, okay, all the objects follow one law, and that law is what we call as a universal law of gravitationals. In the previous topic we have discussed that. Okay, in the entire universe, okay, in the entire universe, all the objects, okay, in the entire universe, all the objects follow this law. Okay, in the entire universe, all the objects follow this law. Okay, they obey the universal law of gravitationals. What does the universal law of gravitational says? Universal law of gravitational said that, okay, the two objects exert a force. Okay, and two objects exert a force, and that force is directly proportional to the mass of the two objects. Okay, mass of the object 1 and mass of the object 2. Okay, if the mass of the object, the product of the mass of the object increases, then the force also will be increasing. Second is what? The force between the two objects, okay, will be inversely proportional distance between the two, the squares of the distance between two objects. Okay, by formulating these theories, we have learned that force is given as Q is equal to mass of the product, mass of the M1 and M2, okay, M1 and M2 divided by distance squares. So this is what the universal law of gravitational give us. Okay, universal law of gravitational give us that force is equal to G into product of the two masses divided by distance squares. Okay, so from here also we have discussed that what is the unit of the G and what is G. Okay, we have learned that G is the universal constant, universal gravitational constant. Okay, and what is the value? 6 point. So we have also learned that 6.673 into 10 to the power minus 11 Newton meter squares per kg squares. Okay, so this is what we have learned in the previous video lectures. And this video today will not be going to any other video live. We will not be going to any new topic, but we will discuss. Okay, we'll discuss a new on the basis of this. Okay, based on this, we'll discuss some numerical problem. Okay, what are the numerical problem? We'll discuss on this. But just I'm highlighting the video, revising all those things. Okay, so we have also discussed that the values of the G, which is the universal constant. Okay, which is the universal constant. It is a universal gravitational constant. G is what? It is a universal gravitational constant. Okay, universal gravitational constant. The values of this universal gravitational constant, that is what? 6.673 into 10 to the power minus 11 Newton meter square per kg square. So this is our units of these values. Okay, the values of this G. Okay, and this G is always, this universal gravitational constant is always denoted by the capital letters. Okay, that is block letter G. It is always denoted by the capital letters G. I've already told in the previous video lectures so that don't get confused with the small letter G and capital letter G. The small letter G is an acceleration due to gravity. Okay, acceleration due to gravity that we will discuss more detailedly about the values of this, how we have derived the values of this. Okay, what does it means? Everything we will discuss under a topic that is called free fall. Okay, we have already learned how to use this one in the previous motion chapters and the force. Okay, force and the motion chapters. Okay, so but in this chapter is the topic called free fall. Under the free fall, we will discuss about the G more detailedly. Okay, so I want you to be very concerned about this one. So don't get confused with the capital G and the small letter G. What does the capital G stand for? The capital G said that it is a universal gravitational constant. What does the small letter G said? Acceleration due to gravities. Okay. This is what change in velocities. Okay, change in velocity due to the gravities. Okay, the SI, the values is what? This values is what? It is 9.8 meter per second squares. Okay, that we have discussed. 9.8 meter per second squares. Okay, so this is what we have discussed in the previous video lectures. Okay, we have discussed more about this one. Okay, and also we have discussed how we find out the SI unit of this. Again, I'm just rewinding the how to derive the SI unit of the G. Okay. Well, I will just highlight how to derive. Okay, how we can give the SI unit. SI unit of gravitation is what? Newton meter square per kg square. Okay, so we are going to derive how to do this. We know that F is equal to what? G into M1 into M2, that is divided by distance squares. Okay, D square means it is D stand for distance. Okay, distance squares. Okay, so here you see our F. We know that our F is what? Newton, and G we don't know, and mass we know that is kg. Again, SI unit of mass is also equal to kg divided by distance is what? Meter squares. So if I write this one again, Newton's meter squares, okay, is equal to G, that is kg into kg is what? Kg whole squares. Okay, kg squares. So this meter squares, it goes up here and multiplied with Newton. Now if I say G is equal to what? Newton meter square divided by kg, if I send this side become kg squares. Okay, so this is how we derive. Okay, this is how we derive. You can see here. I think it is not visible in the board. So what is it? G is equal to what? Newton meter square is divided by kg square. So this is the SI unit of gravitational proportional gravitational constant. Okay, universal gravitational constant. This is the SI unit, and their value is 6.6673. Okay, I think you're clear about this now. Okay, we are clear about this. Okay, we are clear about this, all those things, and now we will discuss more details about the numerical problems. Okay, the numerical problem, the first question goes here. Okay, this is our first question from an exercise page number 153, that is question number 3. What is the magnitude of the gravitational force between the Earth and a 1 kg of object on the surface? The mass of the Earth is 6 into 10 to the power 24 kg, and the radius of the Earth is 6.4 into 10 to the power 6 meter squares. Okay, this is our first questions. So check out the questions. The first question that I told you, exercise, it is from the exercise page number 153 and question number 3. Okay, so what has the question said? Here you see, first of all, we try to write down what is given in the questions. First of all, we try to write down what is given in the questions. And what is the question asks? Your question is asked, exercise question number 3, page number 153. Page number 153, question number 3. Okay, so this is our first question. What is the question said? You are asked to find the magnitude of the force. Magnitudes of the force. Magnitudes of force. That is, F you have to find. Okay, magnitudes of the force. Okay, magnitude of the gravitational force between the two objects. Okay, that is object between the two objects. That is between the two objects. That is earth and the one is an object. So okay, whatever the object may be. Okay, so you have to write down what is given. You're asked to find the magnitude of the force. Okay, and you have to write down. Always remember whenever you're solving the numerical problem, either in the mathematics or either in the physics questions, you have to write down what is given in the questions. Okay, and you have to indicate that very questions, very dadas, okay, with the symbol. That will become very easy for you to utilize the formulas. Okay, but if you don't write the questions, if you don't read the question nicely and you don't know what data is given in the question, that become a problem for you. Okay, so always remember that you have to write down what is given in your question. Okay, so you have to note it down before that. With what formulas? Okay, what you are going to, what is the problem? What is the question that has been asked? You have to read that one, and based on that, you have to use the formulas. Okay, the first thing is what given. Mass of an object is given. Mass of an object is given. Mass of an object, let's say mass of the object, let's say capital, small letter m. Okay, small letter m, that is 1 kg. Okay, then mass of the earth is also given. Mass of an earth is also given. Let's denote this by a capital M. That is 6 into 10 to the power 24. 6 into 10 to the power 24. 10 to the power 24 kg. Okay, next. Radius of the surface. Radius is given. Radius of the earth is given. Radius of the earth. Okay, this is of the mass of the radius of the earth is given. Radius of the earth is given. Let's say radius is denoted by capital D, small letter d. Okay, or you can also denote it by r also. Doesn't matters. Okay, so r. Okay, we have denoted by r. That is equal to what? That is equal to what? 6.4 into 10 to the power 6. 10 to the power 6 meter. Okay, this is our meters. Okay, they are given in the unit called meters. Okay, so there is no problem. Again, we don't have to change this into centimeter, from centimeter to meters, or this is it. Okay, so directly the unit is given. So there is no problem there. No changes will be there. Okay, next, our question is what? We know that the universal constant, that is G is, we know, 6.673 into 10 to the power minus 11 Newton meter square per kg. Am I right? So this is what our value is given. Okay, this is what our value. Please note it down all this, and then based on this we will try to solve the numerical problems. Okay. So what is our question say? Our question is to find the force of the magnitudes. Okay, the magnitude of the force. Magnitude of the force. Magnitude of the force. Magnitude of the force between what? Between the mass of an object and mass of the earth. Okay, between these two we have to find the force. That means we know that F is equal to what? F is equal to what? G capital M and M divided by D squares. Okay, we can write D squares, or we can also write or G capital M and M divided by small letter r. Okay, r square. G or r is same thing solely, or equal to. Okay, equal to anything, because we here our distance is in the form of radius, so I'm representing d by r here. Okay, now substitute all the values in this equation. Okay, substitute all this value in the equation. Okay, so I'm just rubbing all this. I think you have already noted down all these values, so I'm just noting down all these values. Okay, removing this. Okay, then now I'll put the values out here. Okay, F is equal to what? G is how much? 6.673 into 10 to the power minus 11 into F. M is what? M1, capital M is what? 6 into 10 to the power 24 into M, small letter m is what? 1. Okay, divided by what is it? D squared, that is 6.4 into 10 to the power 6 whole squares. Okay, so here it is what? Newton. Okay, the force is represented always in the form of Newton, capital N. Okay, that is always represented by the capital N. Okay, I think you can easily solve this one, right? Let's try to solve this one again. Let's try to solve the problems. So I'm rubbing this one. So here's F is equal to 6.673 into 6 into 10 to the power minus 11 plus 24. Why? We know that if the base am to the power and an, if the base are same, powers are different, that means our power get added, right? So here's 10 to the power minus 11 and 10 to the power minus 10 to the power 24. That means the power will get added here. Okay, minus 11 plus 24. Divided by what is it? 6.4 into 10 to the power minus 6. So multiply this two times, that means what? 6.4, okay, 6.4 squares into 10 to the power 6 into 2. Okay, so what is it? It is Newton here. So what do you get here? F is equal to what? 6.673 into 6 divided by 6.4 into 6.4 into 10 to the power 11 minus 24 is how much? 2, 3, 2 minus 1 is 1, 13 into 10 to the power 12. Now again, if I subtract this one, if I cancel this one, 1, 1, that means 13 and 1, that means what? Our answer will become 6.673 into 10 to into 6 divided by 6.4 into 6.4 into 10. Okay, now you can start multiplying, so division by the 2. Okay, we can start multiplying and dividing by 2. Okay, so 2 3 is 6, 2 2 is 4, 2 3 is 6, 2 3 is 6, 2 2 is 4, 2 5 is 10. What is the answer remaining here? Okay, 6.673 into 3 into 5 divided by 3.2 into 3.2 Newton. Okay, now multiply and divide it. Okay, divide it again. So 2 1s are 2, 2 6 are 6, 2 6 are 12, 2 3 is 6, 2 3 is 6, 2 3 is 6, 2 6 are 12, 2 5 is 10, 2 1s are 2, 2 6 are 12. Okay, so here again, 2 1s are 2, 2 6 are 12, 2 6 are 12, 2 8 are 16, 2 2 are 4, 2 5 are 10. So what is remaining here? 1.66825 into 3 into 5 divided by 1.6 into 1.6 Newton. Okay, so this is what we are getting here. Okay, I think this is what we are getting here. So we'll try to multiply all this and divide it. So now, if I multiply this 1.66825 into 3 into 5, then if I multiply all these numbers, if I'm not wrong, okay, I've just calculated this one, that means your answer will become 25.02375 divided by 2.56. Now divide 2.56 with this, you will get 9. So if you divide this, you will get 9.77 Newton, which is nearly, it is, if you take out the round off, it will become 9.8 Newton. Okay, so the force between, the mass of an object and the earth, okay, the force between the object and the earth is nearly equal to 9.8 Newton. Okay, the force between the mass of an object and the mass of an earth, it is 9.8. Okay, so this is our first question. So I believe that you have already noted down all these things. Okay, and you can just solve it out. Okay, you will get the same answer, that is nearly 9.77 Newton in 9.8. Okay, so let's go with the next questions again. Okay, that's our question numbers. That is question number 23. Okay, question number 23, batch number 155. Okay, based on this topic that we are discussing, will be discussed. Okay, so question number 23. What does the question number 23 says? Calculate the force of the gravitational between the Earth and the Sun. Given that the mass of the Earth is 6 into 10 to the power 24 kg, and the sun is 2 into 10 to the power 30 kg. The average distance between the two masses is 1.5 into 10 to the power 11 meters. Okay, so we are asked to find out the mass of the gravitational force of the gravitational between the earth and the sun. Okay, now you see this is our question number 24, I think. I'm sorry, question number 24, question number 23 is question number 23. Okay, your question is already will be displayed in your screen. Okay, so then you can refer. So here is the solutions. First of all, I told you to write down what is given. Okay, mass of the earth is given m. Let's say small letter m. Okay, mass of the earth is given m. That is, mass of the earth is given m. Okay, so that is equal to how much? 6 into 10 to the power 24. Mass of the earth is 6 into 10 to the power 24. 6 into 10 to the power 24 kg. Okay, 6 into 10 to the power 24 kg. And the mass of the sun is given. Mass of the sun, capital M, that is equal to what? 2 into 10 to the power 10. 2 into 10 to the power 30 kg. Okay, so here's our average distance. Average distance is given. Average distance, that is D, is given 1.5 into 10 to the power 11. 1.5 into 10 to the power 11 meters. Okay, you're asked to find the force. We know that F is equal to what? G_mm divided by D squares. Now put the values. So which implies that F is equal to what? G is how much? We know G is 6.673 into 10 to the power minus 11 Newton meter square per kg. Okay, into mass is given how much? 6 into 10 to the power 24 kg into 2 into 10 to the power 30 kg divided by distance is given 1.5 into 10 to the power 11 meter squares. So here you see our kg, 1 kg squares and kg got cancelled. So F is equal to what? 6.673 into 10 to the power minus 11 Newton meter squares into 6 into 10 to the power 24 into 2 into 10 to the power 30 divided by 1.5 into 10 to the power minus 11. Okay, 1.5 squared, that is 1.5 into 1.5 into 10 to the power minus 11 into 10 to the power minus 11 meter squares. So this meter squares and this meter square also get cancelled. Now you're clear about this one. Well, what's the value is it now? F is equal to what? 6.673 into 6 into 2 into 10 to the power minus 11 plus 24 plus 30. Why we are doing this one? Because their base, they have a same base but the powers are different. That is why we are adding the powers. Okay, we are adding the powers. So 1.5 into 1.5 into 10 to the power minus 11 plus minus 11 become minus 22. Okay, minus 11 plus minus 11 become minus 22. I think you're clear about this one. So up to here we have arranged all the equations. Okay, so the more we arrange the equations, that must become easier in calculating the numerical problems. Okay, so now F is equal to how much? 6.673 into 2 into 10 to the power, how much it is? 24 plus 3 is how much? 30 is how much? 24 plus 30 is 54. 54 minus 11 is how much? 30. 3, 4 minus 1 is 3. 5 plus 1 is 5 minus 1 is 4. How much it is? 43. Again, divided by, we have again one more 6 zeros. Divided by what is it? 1.5 into 1.5 into 10 to the power minus 22. So if I multiply this again, if I write this one, 6.673 into 2 into 6 into 10 to the power minus 10 to the power 43 minus 8 minus 22 divided by 1.5 into 1.5. I think you're clear about this one. Okay, so this is how we are 6.67 into 2 into 6 into 10 to the power minus 43 minus bracket minus 22, because the powers here the same base but the powers are different, so that means they are in a division. That means the two power will get subtracted, okay, by using a to the power m divided by a to the power n. Okay, so law of exponent it is. Okay, so by using the law of exponent, so I'm rubbing this one. Now here's our equation become f is equal to what? 6.673 into 2 into 6 into 10 to the power 43 plus minus become plus 43 plus 22. How much is this? 565. How much is this? 65 divided by 1.5 into 1.5. Well, if I want to remove this point, that means I have to multiply again by 100. That is 10 to the power 65 into 100. If I multiply by 100, that means down here 15 and 15. Okay. The point, if I want to remove point, is 2. That means I have to multiply 100 here. Okay. So if I multiply this 100, now what do I get here? Now start cancelling. 2 3 is a 6. 3 2 is a 6. 3 5 is a 15. 5 3 is a 15. 5 2 is a 10. 5 2 is a 10, 0, 5 4 is a 20. So what do you got here in above? F is equal to 6.673 into 2 into 2 into 4 into 10 to the power 65 divided by 3 years. So divide it and multiply. If you multiply and divide it, okay, you will get the exact value. That is, we have forgotten to write one thing, that is Newton. Every time we have to write down this Newton, okay, because we are calculating the word newtons. Okay, so every time we have to write down this newtons. Sorry, here we have done one mistake here. Here we don't have any minus here, so we have put the minus sign. Actually, the question doesn't have any minus sign. I just check it out. So here it will be no minus sign. That means if you subtract this 43 into 22, so you have to subtract this 2. That means it will become 1. 4 minus 2 will become 2. Okay, so here it should be 22. Okay, here it should be 22. Okay, so here also we will get a 22 out here. So here also we will get a 22 out here. So actually I wrote minus 11. Okay, so there should be no minus 11. Your question is also, it is already written, it is 1.5 into 10 to the power 11. Okay, so I wrote it minus 11. That is why we have some problems out here. Okay, so here you see, that is what we have. So divide it. 3 to the 6. Okay. So you divide it, you will get nearly 3.5 if you divide it by 3 to these numbers. Okay, so we'll just try to multiply this all the numbers. Let's try to multiply all these numbers and then divide it by this. What is it? 6.673. 2 2 is a 4, 4 4 is a 16. Multiply this 2. 6 3 is a 18, 1, 6 10 is a 42, 43, 4 in n. 6 6 36, 36 plus 4 40, 4 in n. 6 36, 40, 40, 6 3 7 6 6. Sum of these two 8 9 7 6 0. Okay, so how many number point? 1 2 3. So 3 point, that means 106.798 into 10 to the power 22 divided by 3. Okay, so multiply this. 3 3 is a 9. Okay, so 3 3 is a 9. 3 3 is a 9. Point again. 3 3 is a 9. 16. 3 5 is a 15. Again, it will go. So if you divide, I will just do the division on this side. So we'll get 106.798. So 3 is a 9.3616. 3 5 is a 15. 15 1 7 3 5 is 15. 15, that is 29. So 9 3 is 27. Okay, so in this way, if you calculate this one, you will get nearly, nearly you will get 3.56 into 10 to the power 22 Newton. Okay, so this is how our answer is. Okay, so here is 43. This should be 21, not 22. It should be 21 years. Okay, here it should be 21. I'm sorry, I have done some numerical calculation. Here it is 21. Okay, so if you calculate this one, it will become 22. So if I move this one exactly, it will become, your answer will become 3.66 into 22. So if I move this 21, so if I move this point in front, that means what, 3.56 into 10 to the power 22, it will become, since it is 21 here. Then if I move this one point this side, that means your power will increase. Okay, so this is how we reduce. This is how our force is. Okay, this is your force between the sun and the moon. Okay, force between the sun and the moon. Okay, so this much force will be producing, exerting on each other. Okay, so this is all about the questions on the numerical problems. Okay, so we'll solve one more extra questions. Okay, from the outside. So this is an extra questions for all of you. Okay, so how we are going to solve apart from some additional questions which have been given. Okay, like not from the exercise, I'm just letting you to know from, like, apart from the others examples or extra questions. Okay, so let's say if find the gravitational magnitude of the force between the two objects. Okay, if the mass of one object, okay, if the mass of a body 1, okay, mass of body 1 m is equal to 2 kg, example, and mass of body 2 m, capital M, let's say it is 2 into 3 into 10 to the power 4 kg. Okay, so distance between them, okay, distance between them, I'm just taking out a very simple question. Distance between them is d is equal to let's say yes, 0.12 meters. Okay, so let's try to solve this way. Okay, so not less 0.92, let's say 0.8. 92 will become very difficult to solve out. Okay, so it is very difficult. Let's try to solve it. So find the force. We know the force is equal to what? Gm divided by d squares. So we know that g is what? 6.673 into 10 to the power minus 11 into mass m is 2, another mass is 3 into 10 to the power 4 divided by what is it? 0.8 whole squares. So calculate this one. Force is equal to what? 6.673 into 10 to the power into 2 into 3 into 10 to the power 4, 11 minus 11 plus 4 divided by 0.8 into 0.8. So calculate this one. So when I calculate this one, okay, our calculation will become nearly 6.673 into 10 to into 2 into 3 into 10 to the power minus 7 into 100 divided by 8 into 8. So 2 4s are 8, 2 25s are 100. Okay, so this way you multiply this one. Okay, 6.673 into 3 into 25 into 10 to the power minus 7 divided by 8. So multiply these two and calculate it. So if you multiply these two and calculate, you will get some values. You have to put in newtons. I always forgot this to put in newtons. Okay. So if you multiply this one, okay, if you multiply this and divide it by this, then you will get 62.5 into 10 to the power minus 7 Newton. So it will get nearly F is equal to what? 6.25 into 10 to the power minus minus 6. Okay, 10 to the minus 6. So this is our force. Okay, so this is our force. Clear about this one? Okay, so this is our force. You can see this is our force. Okay, so this is how we do the numerical problems. Okay, and let's try to solve. This is all about the law of gravitational, and we have learned how to use the formulas of the gravitational. And the next video lectures we will discuss about the free fall in the next video lectures. Okay, so I believe that you have understood all those things. Okay, let's meet in next videos.